All right, so today we're going to be going over SQL queries within the Grafana dashboarding. So this is the dashboard that we're going to use as like a testing ground dashboard. And I'm going to try to make this video so you can find the tags for each one of these. So we're obviously going to be doing stats, we're going to be doing time series, we're going to be doing histograms, pie charts, the map one, and then what I would just call like a list or table version. So this is a pretty straightforward data set. I'll link the actual GitHub repository so you can recreate this yourself, including the JSON for these for this dashboard. But basically, we're going to go ahead and get into it. Now, one thing I do want to take note of really quick is this documentation here. So in the InfluxDB documentation, specifically for InfluxDB Cloud Serverless, which is our v3, which is SQL, it's using the Apache Arrow Data Fusion implementation of SQL, which means there are slightly differences to just your normal SQL that you might use in like an Oracle database or even a MySQL database. But this documentation is really great to go over, some of the more basic and advanced versions of SQL. Again, this is going to be mainly focusing on just getting this working in Grafana and just how you can visualize some things. But I would suggest checking out the documentation. For example, we can start with something very simple like selecting A and B and time, for example, from measurement. So in this example, it's selecting everything from H2O feet with a limit of 10. That basically just means give me the most recent 10 results if I select all from. For example, you'll see this result here, or you can select specific tags and fields. I'm showing this just to kind of give you an idea on how this data looks. So you can already see right here, this one's very similar to the aircraft type. So let's go ahead and go into this. All right, so now we're within the Grafana editing. So we've got this set to table. So that's what we're seeing here. We're seeing aircraft type as a table. Great. It's pretty straightforward here. Now, one thing to note is when you first come in here and you're going to pick your data source, and depending on how you set this up, it might already, be set, but you're going to select your data source. Mine is a v3 influx data source. From there, you're going to go ahead and, as you can see, we are selecting, specifically we're using distinct. So we're using distinct to say only give me unique aircraft types because, for example, an Airbus 332, there might be a few of those in the air, but we just want to see the distinct ones. So this is just all of our unique identifiers. And all these are coming from flight. So one thing to note is that when you first come in, you'll probably see this. You'll see the builder. So from the builder, it can be pretty straightforward. You could do something like from flight, I want to go ahead and get aircraft type as a column. Now, the only thing to note here, though, is that distinct is not an option that I can just add here. Now, of course, it could just be that I'm not the strongest at using the builder. It's certainly possible distinct is an option here that I'm just not seeing. But I find that it's just a little faster for me to just use the code because I'm just used to it. So it copy and pasted this for me. So I can just go ahead and paste that back in and run my query. Looks fine. So yeah, you can use the builder if you would prefer. I think for one or two of these examples, I actually am using the builder. But for the most part, I find the code side to just be a little faster and a little easier, especially because if you're already used to writing SQL, it's just so much easier to just, write SQL. But you do you. It's whatever makes you comfortable. So let's go ahead and look at destination cities. So as I said before, destination cities, for example, is using the builder. But you can still see the preview code down here. So you can see that we're selecting all the destination cities from our flight data, and we're grouping by destination city as well. So we can see all of our destination cities where all of our planes are going. Again, this is a table, pretty straightforward. Go ahead and apply that. Origin cities is literally the exact same thing. The difference is just that we are getting origin city instead of destination. Now, if we didn't do the group by, we would see a result more like this, where we would see a lot of repeats. But we want to group by the column so that way then we only see a small list of results. So we don't see, 20 Philadelphias. We just want to see this kind of list. So going down to the next step here. So this one is very straightforward. So this is using the average function. So we're selecting the average altitude from flight. So this is aggregating all of the altitudes from all of the flights. It's not, per plane, I guess you could say. It's the average. So you can see an example of that so for example, here in the documentation, you can see SQL aggregate functions. So I am using the average function. I'm asking for the average of an expression. There's also options for things like the mean or the count, the max, etc. Now, one thing to note here, though, is that within the builder, so let me go ahead and copy my code. In the builder, you can also do aggregations as well. So in here, I could say something like altitude, and then I could go ahead and do the aggregate average, run my query, and it would be pretty much exactly the same. It has rebuilt the exact same query. Now, obviously, this list is like 7 options. The full aggregate list is much larger. So we have our general aggregate functions, which, to be transparent, are the ones I would more commonly be familiar with. But then we also have our statistical aggregate functions, which are more for people who are obviously dealing with like statistical analysis, and approximate aggregate functions. So I just wanted to mention the fact that there are, a wider range, and this is again why I suggest using the code instead of the builder, because the more complicated your query is, the more likely it is that you're going to need to use the code. So for example, if I wanted to do something like, I think first or last value isn't available here. Yeah, if I wanted to do first or last value, I could do it in the code. That being said, I do think there's some options on the right-hand side within Grafana where you could kind of change this calculation. Like maybe I could get like last value here or first value. It doesn't seem to be changing. But basically, I think the better solution here would just be to use the code version instead, if you need to do one of those more advanced aggregates. This one is very simple. So what we're doing here is we are counting the amount of flights in the air. So this is again a stat. So we are selecting all the idents, and we're grouping by the idents as well, because the ident is basically the unique identifier for our planes. And then on the right-hand side here, we are using count. So as I mentioned before, we have this right-hand side where you can kind of allow yourself to manipulate the data that you've received back. Now, again, this is not always going to work. Like, for example, that mean obviously did not work for me, but count does work. So I'm calling from an API for this, so it's obvious that the count has gone down. Most likely that just means that some of my data is falling off in the past couple minutes. So if I go ahead and change this to be like last 30 minutes, yeah, we'll see it jump back up. So it's just my data changing. But yeah, so on the right-hand side here, we're using that count. So we've gone through pretty much all the table and all the stats. So now let's go ahead and take a look at our time series. So let's also go ahead and drop this down to 5 minutes so we have, a little bit of a clearer view here on what's going on. So basically, and again, we'll look at this one through the builder. So we've got our column of ground speed, time, and ident. So we want all these because we're going to use them to basically determine which flight that we're following and the overall ground speed that it has. So ground speed for a plane is how fast it's flying within the air, basically. So if a plane is down here, like on the ground, it's got a ground speed of basically 2. That probably means it's taxiing, or it might even be, it's on the ground for all intents and purposes. It's going so slow that it's basically probably on the ground. But planes like this, so you can see our plane here in the green, that would be a Delta flight that by the looks of it is taking off most likely, because you can see that the ground speed is going up. Same with this yellow one. This red one, though, and the orange one as well, are both kind of starting to go down. So they're probably coming in for landing. Same with this blue one right here. The Southwest plane is most likely coming in for landing. So that's kind of how we can see this over time series. Now, one thing to note about this that's very important when you're using Grafana and Influx together is the transform data function and partitioning by values. So if I did not have this, let me go ahead and remove it. This is how the data would look. It would just look quite strange. So instead, what we need to do is we need to transform the data. So you go to add transformation, and you specifically want to look for partitions. You could just look it up at the top. You could just type in the word partition and partition by values. Makes it probably the easiest. You go ahead and select your field. So the field you're selecting is the one that will make a unique identifier. So for us, it's going to be that ident. Then you can say that you want as the frame name or as the label. So I'll go ahead and switch it to frame name, and then you can determine if you want to keep the fields or not. That's up to you. But basically what this does is now the data is completely separated out based off the planes. So again, you can see this purple one right here. That's the Southwest flight coming in without a doubt for landing because the ground speed is going pretty far down. And if you're curious why, for example, this yellow plane is starting to, disappear, it's not here anymore. What that means is that we are boundboxing our data set. So we are within the airfield of Las Vegas, Harry Reid International Airport. And basically, as the planes fly away, they tend to disappear off of our radar. So that's why you see that flight just kind of pop away all of a sudden. That means it flew out of the bound box and we're no longer tracking it. But yeah, so the big thing here is the transform data is super useful. I'm actually using it as well. So we're going to go down to this one. I'm using it for this one as well. But here I've gone ahead and I've just done the code. If you're curious what makes me switch between builder and code, it was probably just whatever was most convenient at the time. There's really no rhyme or reason per se, because again, this one's extremely similar to the one we just looked at just with altitude. And again, the transform data, all we're doing here is we're doing it by ident. Now, one thing to note that I did do here that's a little different because I needed to for the bar gauge. So we're dealing with a bar gauge here. And with this data set in particular, I have a lot of flights. Maybe not right now because, one second. Maybe not right now because I don't have as many to scroll through as you can see. But if I change it to like last 15 minutes, I'll have quite a few more options here. And so when I originally had this, I had it to the auto. And this was very hard to read, especially the more planes I get in my data set. Yeah, so imagine at one point I had so many flights, it was really hard to read. So I went ahead and changed it over to the horizontal to make my life a little bit easier. You can also go ahead and kind of mess with this. You can do retro. Gradient. I decided to do the retro. And then another thing you can do down here is the threshold. So for example, I have our threshold set for like 60. I could also change it to 100, though none of the flights right now are within that. But if I drop it up here, there we go. So anything flying above 100 altitude is probably going pretty far. It's not a short flight. Anything low altitude is probably either in takeoff or landing. So we'll go ahead and leave the bar gauge here, apply that back. So now we'll go into our bar graph, so now we'll go into our pie chart. So the pie chart is one that, again, I've decided to go ahead and use the code because I'm specifically doing multiple queries here. So I have queries A, B, C, D, and E. And obviously I could add some more if I wanted. But what these are doing is we're dividing the idents by their unique characters. So we're using the and, ident, like, and then this hash symbol. And what this basically says is it is comparing the ident string and it's looking for those values. This needs to have these kind of values here because the actual ident will be called something like AAL123. It will have a flight code at the end of it. But basically, and we're also using distinct, so we're counting the distinct idents, and we're renaming them. So when it comes back to us, as you can see here, it will say American Airlines. So we are renaming it, we're selecting the distinct count from the ident, and we're going ahead and looking for something like AAL, which indicates that it's an American Airlines flight. We're doing the exact same thing here for United, which would be UAL, for Delta, for Southwest, and for Frontier, because those are the major airlines that will fly out of this airport. So within the docs, these are known as SQL logical operators. So the and will return if both operands are true, otherwise it returns false. You can use something like a between, an exist, an in, a like, a not, and an or. So obviously we are using the like. So this is if the left-hand operand matches the string pattern specified. So as you can see here, select John, like, I can't even try to say what that's saying, but we'll go to this one. And basically what we're looking for is anything that matches the ampersand room, which for this one you'll see that it's returning back living room. That makes sense. And I'm not going to go into each one of these logical operators, but I just wanted to point out that this is where you'll find them. They'll be within operators, and then there'll be logical operators. There are also options for things like SQL arithmetic operators, the comparison operators, things like less than or equal to or matches, bitwise operators, which I personally haven't used too much of, and of course the other operators for concatenating strings, for example, or time zones. So these are just some other options that you can have if you need to deal with timestamps, time zones. And I didn't change any of the right-hand fields on this one. It's all exactly as you expect it to be. You could go ahead and change it to pi or donut, but yeah, I didn't touch the right-hand side for this one. It's just all in the code. So finally, we'll go to our map one. So you can kind of see a pattern here, by the way. You can definitely see like this circle here. That is the takeoff and landing path for Harry Reid International Airport, which is sitting in the center of all these dots. So if you're curious, that's why the planes are kind of lining up like this. And some of these planes, like for example, these orange dot lines, some of these are also multiple planes, like we're tracking the plane as it comes through and it's being mapped multiple times. Yeah, so we're not currently limiting the map on the ident. So for example, we can see that this was a value for NI Chi flight that's going from Sacramento to Harry Reid International. And as you can see, we're kind of watching it as it flies in. Now, obviously, it probably has to get in line here and get into the flight path for actual landing. But yeah, because we're not limiting it on the ident, we'll see a few repeats of some of these planes. So again, if we drop this down to 5 minutes, we won't get so many of those repeats. This one is most definitely a code just because there's a lot going on here. So we have to select our latitude, our longitude. We're selecting the altitude so we can show it within the drop-down. Same with our ident, our origin and destination name. And we're grouping by all of the above. So we're grouping by all of these. And then when it comes to the map, basically the way that this tends to work is you go to your right-hand side here. And mine's in auto. So I have latitude and longitude as my chords. That's actually what they're called within my database. So I don't have to do very much here because it just automatically finds them. Sometimes you have to specify your chords though. Like you have to specify which fields are your latitude and longitude fields. Luckily for this data set, I don't have to. One thing I did do for this data set though is I did add thresholds. So anything below the 50 altitude is at 50, anything above 100 is orange, and anything above 150 is purple. Which right now we don't see any purples, but if I go back to like the last 30 minutes, we'll see some purples here. Purples almost always indicate that the flight is going onward. So for example, this was a flight that, again, because we're not doing distinct idents, which we could do, and then that would remove some of our dots. This is a flight that's going from Los Angeles to JFK. So it's actually flying in this direction. It's definitely going to the right side of the airport. But the reason it's flying so high is because it's not landing here. In general, that tends to be how the purples are. The purples tend to be values that are going onward. Like, for example, this one actually left. So it left Harry Reid, and now it's on its way to Frankfurt. So pretty much took off right away and started to gain altitude. Same with this Denver one as well. So yes, again, this is the landing path on the right-hand side, the takeoff path on the left-hand side, where you'll see everyone kind of make their turn here. But yeah, that's just your basic dashboard with a few little tips and tricks on working with Influx within this. Obviously, like I said, I didn't go over every single thing within the documentation here, and I do suggest checking it out. It has a lot of great examples that you can pull from. The only thing that occasionally will get tricky when you're dealing with Grafana in particular is the time. So you probably noticed, if you saw this here, you'll see this where time is equal to from time from and time to. That is obviously being fed in from up here. That's coming, it's a past variable for Grafana, but that is something just to keep in mind when you're dealing with stuff like this, is that some of these are going to have to be edited. Another thing I would suggest to you, again, remember that this is using Apache Arrow Data Fusion. If you have ChatGPT or some other like AI that can help you write SQL code, if you tell it the version that you're using, the Apache Arrow Data Fusion, it won't have the most up-to-date docs, most likely, but it will have the most up-to-date docs it has, and it can probably help you write that implementation of SQL. That is one thing to note, is if you just ask for straight SQL queries from ChatGPT or another form of AI, it will normally just pull from something like the MySQL docs or the Oracle docs or whatever SQL docs it can get a hold of. So just do be aware of the fact that we're dealing with the Apache Arrow Data Fusion. But yeah, I hope this was a lot of help. Again, I will link within the description if you want to check out the actual project. If you want to download the JSON file, I'll link all that at the bottom, and then you can go ahead and check it out for yourself. Thank you so much for joining me on this fun little video.